Hi, welcome to another video of machine learning. So today I'm going to start with a very simple machine learning model that is called logistic regression. So I hope that most of you have an preliminary idea of what logistic regression model is, and also you have some basic understanding of probability. Okay, so with this, so I'm in this lecture or in this video, I will touch upon precisely the logistic regression model and as a probabilistic model, and I will try to investigate some very basic important concepts of logistic regression and starting from the basics. And probably particularly I will discuss that why the logistic regression model is called a probabilistic model, and where from this logit term comes in logistic regression, and what are the various important aspects to train a logistic regression model. Okay, so first thing to say is that the logistic regression is not a regression. It's not a regression, but a classification learning algorithm. Okay, then why this regression term comes into the picture? Comes into the picture because that the mathematical formulation of logistic regression is quite similar to that of linear regression. That's why this regression terms comes into the picture. And another thing, this logistic regression is also called logit regression. Okay, so this logit term comes from the statistics, and we will discuss what is logit, what basically mean by logit in statistic, and we'll discuss. Okay, so I explained that the logistic regression on the case of binary classification, so it's basically a binary classification model, but however it or naturally be extended to multi-class classification problem in different ways, and that I will discuss in some other video, but that is another aspects of logistic regression. Okay, so logistic regression or logit regression is commonly used to estimate the probability that an instance uh, belongs to a particular class or not. So basically it estimates a probability of a class. Okay, and so it's estimate a probability, and in the second stage, based on this probability, a threshold value, it 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 predicts that whether the instance belong to that class. Maybe it is positive class and it is labeled at 1, and otherwise it predicts that it does not belong to that class, then it will say it is going towards negative class, it will or labeled as 0. So this makes a binary decisions, so it is a binary classifier. Okay, so just for an example I can say that suppose you have a data set where you have the height and weight of different persons, and you have the on corresponding labels whether the person is a male or female. Okay, so if she is female, then it will be suppose, if it is male, then suppose it is labeled as 1, and if it's a female, then it is labeled as 0. Okay, and then you will, in this type, suppose you want to build a model where you want to predict whether for some unknown, for some new height and weight, unknown height and weight, whether this person is, what is the probability that this person may be male or female. Okay, so this is one example, and there are various examples where you can apply this logistic regression. Okay, so let's come into the mathematical formulation. So how does logistic regression work? Just like a linear regression model, a logistic regression model first computes a weighted sum of the input features. Suppose you have total n input features. Okay, just suppose you have n input features like here we have height and weight. Suppose for some problem you have in such features. Okay, suppose in such features, and from this what you are going to do, your logistic regression model will first create a weighted sum of the input features plus a bias term. This is called bias terms. Okay, so this bias terms, and this all are the parameters. So total in W1 to Wn plus one bias term. So total, if you have n features, then your logistic regression model will have n plus 1 parameters. Okay, and so in the first state it will compute this t, this weighted sum plus the bias term, and in the second state what you will do, so this step is just like linear regression, right? And that's why it is called logistic regression. This regression terms comes into the picture. And in the second state what it does is that it apply it outputs the logistic of the result. So it takes the sigmoid, it applies sigmoid function on this weighted sum. Okay, so also it can be viewed as a hypothesis, means that it is a function of this input features where this parameters are associated with the hypothesis or function. Okay, so HW and function of X. Okay, so this is the overall model of the logistic regression model. Okay, so basically what logistic regression is giving you is that once you is give you a probability, a value between 0 and 1, because it is, you are applying a sigmoid function. This logistic function is a sigmoid function. It is a A-shaped sigmoid function, so it outputs a number between 0 to 1. Okay, 0 and 1, so it outputs a value between 0 and 1. Okay, so your P, your predicted P will be a value between 0 and 1. And once the logistic regression model has estimated this probability, okay, once it's estimated the probability, and based on a prediction model of that then we will simply will use a threshold. Suppose this, if the probability is greater than equal to 0.5, then we simply say the instance that the features coming from that instance, that instance is going to it belongs to positive class or class labeled as 1, and if it is less than 0.5, then we will say that this is belongs to negative class or 0. Okay, but question is that this is this fixed, this 0.5, this threshold is fixed, this is a prediction model, and prediction model is governed by the threshold, you can understand here. So is this fixed? It should be fixed always? No, not necessarily. Okay, so if in general case, if when you're you just want to increase your accuracy, but you don't giving any importance to a particular, suppose, precision or recall, then you just your default shooting should be 0.5. But if you change suppose you are for a given problem, if you are giving more importance to recall, then you just need to change this threshold according to your wish or according to whatever you want to build. So this threshold value is not fixed, but by default it should be 0.5. Okay, but this threshold will goes up and down for a particular case when you are just giving some preference over, suppose you are giving preference to recall or you are giving preference to precision, then you should change this threshold value. Okay, So next thing that I am going to discuss is where from this logit term comes. So this logit term actually comes from the statistics. So in the first step of logistic regression over here, you saw that we are calculating this t value, right? T as a weighted sum of the given features plus the bias term. So this t is called, this t is basically then what we are calculating the probability, we are estimating the probability, and so here what we are going to, so applying the sigmoid function. So this name comes from the fact that logit function. Okay, so once then we can express this t as a log of p by 1 minus p, that is called logit function, and is the inverse of the logistic function, right? This is called logistic function or sigmoid function, and this is the inverse of the logistic function, and that is called logit function. Okay, and indeed you will compute the logit of the estimated probability p, and you will find the result is t, right? And the name logit also called log odds. So this is also a probabilistic, it comes from the statistic as called the log odds, since it is the log of the ratio between the estimated probability for the positive class and the estimated probability for the negative class. Okay, so it is the ratio of the, it is log of the ratio of the estimated probability of the positive class divided by estimated probability of the negative class, and also it is called log odds. Okay, so another name for logit is log odds in statistics. Okay, so from this logistics term comes into the picture. Okay, so obviously this is pretty simple, and now the question is, once we know that this is we defined our model, that our defined model has total n plus 1 parameters, right? So our n features, our model going to have n plus 1 parameters including the bias terms. Okay, so next question obviously comes how to train the model. Okay, so the training means we basically want to find out the best parameter that gives the best performance or the least error for predicting the output, right? And for training we use basically the learning algorithm. Suppose you have a training set, and you then what you are going to use is that you are going to use the learning algorithm, and every learning algorithm is some form of optimization algorithm. Okay, so obviously when you are going to use an optimization algorithm, you need a optimization objective, and for this you need to define a cost function or loss function for this optimization. So basically we defined, for logistic regression we defined a hypothesis function, right? Here we defined a hypothesis function like this, right? And HWX function of x. So we need to define a loss function, that or objective function that we want to optimize or optimize using an optimization algorithm. And there are various types of optimization algorithm, and most common one is the stochastic gradient descent or gradient descent algorithms, probably you have heard of, but we'll discuss the more details and how it works and what are the various aspects of gradient descent algorithm. So what are the important aspects here lies is that what should be the loss function for a particular task, right? So what should be the loss function for binary classification or classification algorithm? We know that for linear regression or any type of regression problem, we use the mean square error cost function. But here we basically use the cross entropy or cost entropy loss function or cost function. And but what is the intuitive meaning of this cost entropy, that we need to discuss. Okay, that we are going to discuss in next lecture or maybe subsequent lectures. And another thing is that what should be the optimization criteria, and if we define a optimization criteria in terms of a cost function, then what would be the um, uh, what would be the nature of that cost function? That would be a convex cost function for logistic regression. And if it is a convex cost function, then can we get the optimum solution? Can we get the optimum solution using a gradient descent algorithm? Always. So these are some important things you need to understand. And okay, and obviously when you define a cost function or loss function, is there any closed form equation to compute the parameters, that w and b? So that is also an important aspect, because in linear regression we know that we can use the normal equation to find the parameters from the closed form equations. Okay, but for logistic regression, is there any closed form equation to compute the parameters? Okay, so that is also very important things that we need to discuss. So I don't want to make this video very long. That's why I'm going to stop here, and we'll discuss these topics one by one in subsequent lectures. And apart from this, another topic is that in logistic regression you are having a bias term, right? We're taking a bias term. So how much important this bias term is? So if we neglect this bias term and then train the model, why it is required at all, this bias term? And if we neglect this bias term, what will happen? Okay, that is also very important thing that you need to understand. And another thing is that how we can, so you can see that is a probabilistic model. This is a binary classification, but it is a binary classification model and probabilistic model. But how it can be extended to multi-class classification problem, that also we will look into in the subsequent lectures. Okay, so that's all. I hope it is helpful for you, and please let me know if you have any doubt or you have any more suggestion for me. Feel free to share with me. Thank you very much.